On the AP exam, the intermediate value theorem will sometimes be tested through a problem similar to the ones we did in the previous video. But more commonly, especially in the free response questions, they'll give you a word problem or a table problem and ask you to work through it. So in this video, I wanted to give you a few of those examples. They're very, very simple problems once you see them, but it does require some explanation beforehand. Alright, so for this problem, the outside temperature T in Montezuma, New Mexico is recorded several times throughout the day in the table below. Use the intermediate value theorem to determine the minimum number of times that the temperature was 72 degrees. So remember what the intermediate value theorem is about. Right? The intermediate value theorem basically says if you have an interval that starts below a value and ends above a value, you must hit every value in between those things on that interval. Right? So they want me to find out how many times the temperature was 72 degrees. I mean, if you're up for it, it's not a hard problem. Pause the video, think about what this would be. Well, if we sort of think about it, if the temperature was 65 degrees at 7 a.m. and then 70 degrees at 9 a.m., we must have hit every temperature between 65 and 70 along the way. Right? Same deal here. Between 9 a.m. and 11 a.m., we hit every value between 70 and 74, which means somewhere in between 9 and 11, the temperature must have been 72 degrees. Right? Then between 11 and 12, we went from 74 to 75. Then from 12 to 14 or 2 p.m., the temperature seemed to have dropped from 75 degrees to 71 degrees. Aha, right there again. There was an opportunity for 72 to show up in here. Right? In both these cases, 72 has to have shown up at least once. And then finally, between 14 and 17, between 2 and 5, the temperature continues to fall from 71 degrees to 66 degrees. So the conclusion here is that we must have hit 72 degrees at least twice. Right? Now, could there have been more? There sure could have been. For instance, here, I mean, who knows? Temperature may have gone 70, 71, 70, 71, 72, 73, 72, 73, 72, 73, 74. I mean, who knows? This function could have climbed and then sort of bounced around. Heck, between 7 and 9, there could have been a heat spike up to 72, and then it came back down to 70, and then up to 74. Who knows? All I know is that the intermediate value theorem will guarantee that this happens twice. Again, it's nice to end with some sort of sentence. The other thing I'll say here is that it's important for the function to be continuous. Right? Are temperatures continuous? The answer is yes, temperatures are continuous because the temperature doesn't just magically jump from 70 degrees to 74 degrees. It may get hot very quickly, but the idea is that there is a smooth transition from one temperature to another. I think once I did write a problem like this that was not continuous. I think it was like the number of birds outside of a house. Right? I mean, 3 birds can all leave at the same time. A function like that would not be continuous. This function was continuous. Okay, so let's look at another example here. Throughout a given day, Sonia drinks water from her water bottle and refills it. The volume of water in her bottle, V, which is measured in milliliters, T hours after she wakes up is given in the table below. So once again, we have a function here. And I'd like you to think for a minute, and I'll have you pause the video to do this. Is this a continuous function? Is volume a continuous function? Right? So pause and think about that, and then we'll actually talk about the question. The answer is yes, volume is continuous, because you don't just immediately remove volume. I mean, even if you take a big gulp of water, the reality is you have to pull water through the straw, you have to drink it out, and you don't just teleport a cup of water from the water bottle into your mouth or out of the thing. Right? So this is a continuous function. Now, the question I'm asking is a little bit different. Which of the following values of k, so this is k, which value of k would guarantee that the volume of water in her bottle was equal to 400 milliliters at least twice? So pause the video, think about these different answers, see if you can come up with which one it is. Not a complicated question, but it's something that I've seen before, and a lot of people were sort of confused by it. So think about it. So the correct answer, it turns out, is 200. And the reason that it's 200 is that in order to guarantee that we're going to hit 400 milliliters twice, it has to happen once. It's not guaranteed to happen between here and here. It's not guaranteed between here and here. It's not guaranteed between here and here. The only place we'll hit 400 is between this one and this one, and this one and this one. So 400 doesn't work because we might have dropped from 900 just down to 400 once and back up. This doesn't get low enough, and this doesn't get low enough. So 200 is the only one that makes sense, because it allows for 400 to be hit between 900 and 200, and again going back up between 200 and 500. So that's our correct answer. Okay. So these are two straightforward examples of how these questions can be asked as word problems or as sort of table problems. So be prepared to see those.